Okay, so let's talk a little bit about domain and range. So when we have a coordinate system, not a very straight line there, sorry, this is the x-axis, and it's just like a number line. It has a 0 in the middle. It has positive numbers on the right-hand side that go all the way to infinity, and then we have negative numbers on the left-hand side that go all the way to what we call negative infinity. Then we have the y-axis. The y-axis is our vertical axis. It's still a number line, but it's kind of flipped. So we still have the 0 in the middle. Up above, we have positive numbers that go all the way to positive infinity. And down below, we have negative numbers that go all the way down to negative infinity. So when we're looking at domain and range, we have to, the domain's kind of easy because we're looking from left to right, but the range is tough because we have to look from the bottom up because we always want the smallest number first. All right, so domain is going to be a set of all the x's that our function uses, and then the range is going to be the set of all the y's that our function or our graph uses. Okay, let's draw a line here. I'm sure it's not going to be straight since I can't seem to draw a straight line on this, but we'll draw a line. Okay, so if we're trying to look at how many x's we're using and which x's we're using, what we're going to think about is the width of this function. Okay, because I can't tell you every single x, right? I'm going to have to use what we call interval notation because I have a dot right here that comes down to 0. I have a dot right here. Let's see if I can make a dot that comes down to 1. But I also have all of the fractions and decimals in between. So there would be no way for me to list all of the fractions and decimals and integers all the way up to infinity and all the way back down to negative infinity. So what we do instead is we use interval notation, which I'm going to show you in just a minute. But first, let's just think about this line. Okay, so this line looks like this. And if I tried to contain it in a box, I could do that. My box would look like this, except those arrows keep going, right? And so when those arrows keep going, my box is going to have to get, I need to make bigger. It's going to have to get wider. Let me do it this way. Put some bigger lines in there. And it's going to have to get taller, right? And then it's going to happen again because this line goes on forever. And so again, my box is going to have to get wider, taller, and go down more in the bottom. All right, so you get the point. So what happens is this line is going to eventually take up the entire x-axis. It's going to go way out here to negative infinity. It's the width of this box is going to keep going until it gets out to negative infinity, and it's going to keep going on the right-hand side until it gets out to positive infinity. So what we're going to do when we say interval notation, we are going to start with negative infinity, and we're going to end at positive infinity. Now, I know that looks like an ordered pair, but it's not an ordered pair. It's a start point and an end point. Now, we're always going to use parentheses if we are dealing with negative infinity or positive infinity, because in theory, we don't ever get there. All right, so these are my x's. That's a start point and an end point. And so that is, again, the width of my box. But notice the height of my box. So this would be my height. Well, my height, the box keeps getting lower and lower and lower down here on the very bottom of the screen, but it's also going to keep getting taller here. Okay, so it's going to keep heading downward to negative infinity, but negative infinity always comes first. So this is the tricky part with range. You have to start at the bottom and work your way up. And so it would start down at negative infinity and go all the way to positive infinity. That would be the height of our box, starting with the smallest number. So negative infinity is always the smallest number and going up to positive infinity. All right, let's try another one. All right, so here I have an absolute value function. It has what we call a vertex at the bottom there, and that vertex is sitting at 0, 3, and then it has rays coming out from each side that are headed upward, and they're going to go on and on, hence that arrow. Now in MyMathHub, they don't always put the arrows. I wish they would. Most of the time they do, but if they don't put the arrow, unless there's a dot at the end, it's implied that it's going to go on and on. All right, so we need to find domain and range. Domain is the width of the box that would contain this graph, and then the range would be the height. So let me draw it down here again. A student showed me this, and I just really like this analogy of using a box. All right, so if we contain this graph in a box, it would look like that, but it's going to keep going, right? It's going to keep getting, that's a terrible, I'm sorry. My drawing skills are not good on this Surface Pro. So you notice it's getting wider. It's also getting taller. However, it's not changing down here at the bottom. Okay, so then it keeps going. So you kind of have to visualize. When you look at this for domain and range, you can't look at the graph that's right in front of you. You have to visualize the ultimate graph. All right, so then my box again would get wider and taller, but it's not going to change down on the bottom. Okay, so let's think about this. For the domain, we want the width, and we're always going to start way over here. We're going to go from left to right because this is the smallest number over here on the left. So since this box is getting wider and wider, we're going to go all the way out to negative infinity. And then on the right-hand side, same idea. The box is going to get wider and wider and head to positive infinity. So our domain is going to be the interval starting at negative infinity and ending at positive infinity. You will never find negative infinity on the right-hand side. That's one of the biggest mistakes on the first test. Negative infinity is the smallest number we have. It has to be on the left because we always want the smallest number first and then the bigger number here for the interval. So that's my domain. Now for the range, this one's a little different than the last one. We're starting here at y equal 3. Okay, so if that's our bottom point, and we do actually hit that point. So for the range, we're going to use a square bracket, and the reason we're using a square bracket is because we're actually hitting the 3. With infinity, we always use parentheses. With a number, it just depends. If it's an open circle, we would use parentheses. If it's a closed circle, we would use a bracket. And all that denotes is whether we're actually hitting that number or we're not hitting that number. All right, and then the top of my box is going to keep getting taller and taller, right? And so I would end up with infinity. And the infinity has to have a parenthesis. Okay, so the range is a little trickier because you have to go from the bottom to the top. All right, let's try another one. Okay, so this is also an absolute value function, but it has been flipped upside down, and therefore it's been reflected on the x-axis. So let me draw just to keep up with the box. Now again, you guys probably have another way of looking at this. That's awesome, but if you don't, the box works really well. All right, so let's put this in a box. I won't do a bunch. We'll do one more because this thing gets wider. The box is going to continue to get wider, but notice it doesn't get any taller. It comes down lower, but it doesn't get any taller. So for domain, remember domain is left to right. So because the box is going to keep going this direction out to negative infinity, and keep going to the right to positive infinity, our domain is everything, negative infinity to positive infinity. Sometimes you hear all real numbers, means the same thing. It just means that every single number is used, -5, -4, 2, 3, and then all the decimals and fractions in between as well. So there would be no way for us to list it. Now this one is going to look a little odd for the height. So the height, we have to start down here at the bottom. This thing is moving further and further down as our v gets wider. And so it's going to move down to negative infinity, but it stops up here at -2, right? This is at -2 on the y-axis, and so it stops there. It's not ever going to get any taller. So for our y values, the range, we're going to start at negative infinity. We're going to go all the way up to -2. We're going to actually hit -2. You can see that it's hitting, and so we're going to use a square bracket, but we don't have anything above that, and so we're going to stop right there. All right, let's just try one more. So this is just a line segment. What happens is we don't have any arrows. Notice we don't have any arrows. We have an open circle and we have a closed circle. So with an open circle, we are not actually going to use the number where we landed, but we're going to use the very next teeny tiny decimal next to it. So here we're sitting at -3. So we are not going to include x equals -3 in our domain, but we're going to take the very next teeny tiny decimal after that. So -2.9999999, but we don't want to write that. And so we write an open circle. So with an open circle, we have to remember to use parentheses in our interval notation. If we have a closed in dot, then we actually, so like we have here at 0 in the middle, then we actually hit that point. And so then we're going to use the brackets. Okay, so that's very important. So as we're moving from left to right, the first thing we come upon is, so we're moving this way. The first thing we come upon is the open circle at -3. So since it's an open circle, I am going to use a parenthesis and put the -3. Again, that just means I'm going to start right after -3. So I'm going to start at -2.99999. Then I'm going to keep going from left to right, and I stop here at 0, but it's a closed in dot. And so for the 0 where I'm stopping, I'm going to use a square bracket. And there's no arrow, so I don't use any other x's. There's no x's for me to use over here on the right-hand side. All right, let's do the same thing for the range. So for the range, I'm going from the bottom up. The first time I see anything is right here at y equal to 2. It's an open circle, so I'm going to use parentheses. And then I'm going to head my way up, and the next time I see my ending or the top of my box would be at +4, but it's a closed in dot. And so I'm going to go ahead and use a square bracket. So this looks very different, but that's because we don't have any arrows. When we have arrows, we have infinity. Or like I said, you might see in MyMathLab, you might just see a line like this. If there is no dot at the end, like it'll be an exaggerated dot. If it's just a line, then the arrows are assumed. But if it's a line and they put a big giant dot at the end and an open circle maybe here, that's a line segment. That means it's not going to go on.